Okay, so today we're going to be talking about the Pythagorean theorem, and I think the big thing is that yes, we've spoken about it again, or before, I mean, and what we'll want to do is review it, talk about a few additional concepts, and then also expand on it, talking about an inequality that goes with it. So here we go. So the main thing is the Pythagorean theorem works with a squared and b squared equals c squared. So a and b are legs, and c is the hypotenuse. And a squared and plus b squared equaling c squared only works if you have a right triangle. Okay, and so that is the Pythagorean theorem, and it can be proven. Um, we're not going to do that this year. And so the thing is, if you do the Pythagorean theorem, the sum of the legs squared is equal to the hypotenuse squared. 16 plus 36 equals x squared. To solve the equation, you square root both sides, and you get square root of 52, which breaks into 4 times 13, or 2 root 13, and that would be units. Um, so the length of the hypotenuse is not an integer, which is fine, okay? We could get a decimal by taking the square root of 52 in our calculator, but we're going to leave it as an exact or radical form. That's kind of something we should talk about. We should do x squared plus 12 squared equals 20 squared. So x squared plus 144 equals 400. Subtract 144 from both sides. The square root of both sides is going to give you x is equal to 16, and that's units. And since all three sides are integers, okay, whole numbers, we are going to be saying this is something special. It actually is a Pythagorean triple, okay, where all three sides are integers or whole numbers. Now, some special triples are going to be based on um, these patterns here. 3, 4, 5, 5, 12, 13. These are some of the most common ones. And so a Pythagorean triple means that all three sides are going to be whole numbers, okay? No decimals, no fractions. And then also they have dilations, okay? You can dilate it bigger or smaller. And primarily we go bigger. So if one of the legs is 3, one of the other legs is 4, and the hypotenuse is 5. Okay, how do we know the hypotenuse is 5? Well, the hypotenuse would be the longest side. So in the triple, the longest side is always the hypotenuse. And if you did the Pythagorean theorem on this one, you would get 9 plus 16, and that indeed does equal 25. So 3, 4, 5, and its related dilations. What do you mean dilations? Well, times it by 2, times all three sides, and you get 6, you get 8, and you get 25. That is a lie. 6, 8, and 10 would be a better choice. And if you did the Pythagorean theorem on that, it would also work. So if you want to dilate the original question, like this one right here, by not just timesing it by 2, you could say times it by 3 or 4 or 10. You could get to like 30 and 50 and say 40. And that would also work for the Pythagorean theorem. So here are some basic triples. Okay, 3, 4 were the legs, and the hypotenuse is 5. And then also the multiples or dilations of that as well would also be beautiful examples of right triangles where all three sides are nice numbers. Another one would be 5 and 12 and then 13. Okay, if you do the Pythagorean theorem, you get 25. That's a nice pronunciation. 144. Let me erase that and make it a little cuter. 25 plus 144 is equal to 169. That's true. And then again, all the dilations of it. So times all the sides by 2, and you would get 10 and 24 and 26. Or you could times the original problem, say, by 10 or by 6 or by whatever, and you would get dilations of the original Pythagorean triple that all have integers or whole numbers for the sides. And so you could go with times it by 3, and you get 15, and you would get 36, and you'd get 39. I just copied from here. Again, the longest side of the Pythagorean triple will be the hypotenuse. Another really common one is 5, and then, oh, I lied. We already did 5, 12, 13. 7, 24, and then 25. I tried to make it a little bit to scale. 7, 24, 25, that's a common one. And then you can multiply all three sides by 2 or 3 or whatever you wanted to also build additional Pythagorean triples. So anyway, I think it's good if you recognize there are nice numbers for triangles. They don't all have the missing sides or some of the sides to be decimals or radicals. The next thing we're going to talk about would be if you're using the Pythagorean theorem, it may ask you, hey, is this a triple? And so if you recognize it's a triple, you shouldn't have to show any work, okay? And so we're going to do 14 squared plus 48 squared equals x squared or c squared. It doesn't matter what, you call it. And then you're going to get 2,500 equals x squared. X is equal to 50. Okay. Do you recognize that it's, yes, a Pythagorean triple? And what would be the parent of it? If you divide all of them by 2, you're going to get 7, 24, and 25. So this is the parent of that one there. And you don't have to recognize it. I'm just going to tell you it's there. So if you happen to, it may make your life easier. Okay. And then this one is going to be 4 squared plus x squared equals 12 squared. 16 plus x squared equals 144 minus 16 from both sides. Get x squared is equal to 128. Square rooting both sides gives you 64 root 2 or 8 root 2, and that's in units. So, of course, that's not, okay, Pythagorean triple. Why? Because all three sides are not integers or whole numbers. Integers implies they could be negative, and we don't have negative links on our pictures. Okay. Now, Ralph is going to build a picture frame, so you can deck this up like, hey, he's got a picture frame. And what he wants for his picture frame would be, can make it kind of fancy. He wants the dimensions to have a certain ratio. Okay. That's quite a groovy picture frame. Anyway, trying to make it kind of cute for you guys. Here we go. So the deal is that if he's going to make this, he wants the length to width to be 3 to 1. So if the length and the width are 3 and 1, they're not 3 and 1. And that's their ratio. So when they talk about a ratio, often you will add an x there. Okay. So 3x and 1x. And we want the length of the diagonal to be 12 centimeters. And so if we do the Pythagorean theorem, we do 1x and squared plus 3x and squared equals 12 squared. Now, you have to remember that it's 3x squared, not just 3x squared. It's both the 3 and the x. The entire length is not x, it's 3x. And so you've got to make sure you multiply that by itself again. So x times x is x squared. That's easy. This right here is 3x times 3x or 9x squared. And this is 144. So be careful that when you square 3x, you square the 3 and the x. They're both in parentheses. This is, if you're going to miss this question, generally that's where you miss it. So add these together, you get 10x squared. That's 144. Divide by 10, you get x squared equals 14.4. Square root both sides. You get x is approximately 3.8. And the question is, does it say solve for the ratio, or does it say solve for the lengths? And the answer is it says solve for the lengths. So we go over back to the original problem. And so obviously this side would be 3.8, and that would be centimeters. It says round to the 10th. So that means give me 1 decimal place. And then we're going to do 3 times 3.8 to get this side right here. And that will give us 11.4, and that's centimeters as well. So that's how you'd figure out what these would be using the Pythagorean theorem. For the next one, we've got an actual TV. Okay. And this TV has a aspect ratio of 16 to 9. The length is not actually 16. The height is not actually 9. It's that ratio. because it could be much bigger or smaller than 16 inches. We do know the diagonal of this is going to be 42. So we can do 16x squared and 9 and x squared equals 42 squared. And then when we square it, 16 squared is 256, x squared plus 81x squared equals 1764 is what 42 squared is. Combine like terms here, you get 337x squared equals 1764. Divide by 337, x squared equals something. Okay, and then you're going to square root that value. So that find that quotient and then take the square root of that answer. You're going to get 2.29. And then we can, it says find the actual length and width. So you do 9 times that value. And you do 16 times that value. So the length is going to be 20.59. And that is in inches. If you notice, I actually didn't use this in the formula. I used the entire length, okay, just like you would in chemistry. And then I times it by 9, and then I took this entire decimal and times by 16, and I got 36.61. And that is in inches. Let me see if my calculator's open. Got a lot of stuff open. Let me see if I can find that. Let's see. It is open, okay. So if I did on my calculator, come on, clear. If I took 1764 divided by 337, and push enter, that what I would get. So I do second square root, and then I can arrow up and grab that value and push enter. I get that big number, and so then I can say times that number by 9. That's my first answer, 20.59. I can also arrow up and grab that number and times it by 16 for the other side. So my two sides would be 20.59 as well as 36 or 20.6. Does it say what to round to? No, it doesn't. So if it says tenths, we would keep one place. Hundredths would be 2. So this would be 36.61 or 0.6, depending if I round to the tenths or the hundredths. All right. So let's see what else we've got to talk about. Oh, the converse. Okay. And then also a couple more things. So let's get back to business here. See if I can get my paper open. Here you go. So here's the deal. The converse means the original theorem says if you have a right triangle, then the Pythagorean theorem works. The converse would be if Pythagorean theorem works on a triangle, then you have a right triangle. So to prove you have a right triangle, you can show that the Pythagorean theorem works. And so that's something that we can do. Okay, so that's an important thing. On the flip side, and so we can show that here. If this is a right triangle, okay, then 3 squared plus 4 squared has to equal the hypotenuse squared. Okay, and that would be 9 plus 16 does equal 25. Okay, so therefore it's got to be a right triangle. Now, the inequality theorem, this is kind of interesting, okay? And you can choose to memorize it, or you can choose to understand it, or you can kind of choose to do a combination, okay? Which is probably a good thing. The deal is that if it equals c squared, then you have a right triangle. Okay? However, if you've got two sides, okay, the legs, and then the longest side is actually longer than 5. Okay, so can you imagine what this would be like? 5 is about that big, so maybe it's like 7 or something. So if you do 3 squared plus 4 squared, the two short sides, and then you get 7 squared, okay? If the legs, okay, the shorter sides, are actually smaller than the hypotenuse or the longer side. There is no hypotenuse on a non-right triangle, but if the two short sides squared are definitely shorter, this right here is going to give us 25. And 25 is obviously less than 49. If it's less than the longer side squared, okay, then you're going to have an obtuse angle. Okay, so it's an obtuse triangle. Okay, so on the other hand, if you have two shorter sides and you do 3 squared plus 4 squared, and then if you connect here and here, it is 5 would get you all the way to there. So it's about, say, 4. Well, it's not going to equal 4 squared, is it? Okay. So again, I'm trying to eyeball this and be like, if that's 5, okay, this would be about 7 long. And this right here might be about 4 long. Okay. The actual triangle. And so that means it's this way. If it's greater, then you've got an acute. So you can tell if you have a right triangle, if you know the 3 sides, you can tell if you have an acute triangle, and you can tell if you have an obtuse triangle. How can you tell? You can tell if you have one of those by saying, do the two short sides squared equal the longest side squared? Are they shorter? So less is going to actually be obtuse, okay? So if they're much smaller than the longer side, so less gives you obtuse, then greater than the longest side squared is going to give you acute. Okay. And so it's kind of weird. People want to be like, if it's greater than, it's obtuse. I'm like, no, if it's greater than, it actually means acute. If it's less than, it actually means obtuse. And the pictures kind of show you why. So you can pick, do you choose to hold on to the meaning in your brain? Do you memorize it? How do you deal with, how do you tell from the 3 side lengths if you have an acute, obtuse, or right triangle? Now, one thing we do also need to look for is we have to see, pardon me as I yawn, you have to see if they could make a triangle. If you remember the old rules, that would be the sum of the 2 short sides have to be greater than the longest. Okay, remember you've got a side. If these two are way too short, they're not going to connect. Okay, if they actually equal, okay, the longest side, then you'll have like a folder. Okay, I can't get this thing up here to erase. So you need the 2 short sides added have to be longer than the longest side. So if you did 5 plus 7, it is bigger than 10. Okay, so yes, it's a triangle. And then the question is, what kind of a triangle is it? So is 5 squared plus 7 squared, and then we do 10 squared. We always do the longest side on the right, okay? I'm going to say, is it equal? Is it less? Is it greater than? So we got 25 plus 49. We got 100. And that gives us, so 50 plus 75, that'd be 75, so it'd be 74. So that is less, okay? So then that means this is going to be obtuse. Okay, because if the 2 sides are much less than the other one, then it's going to be obtuse. So let's check this one. Is 5 plus 8 greater than 17? Okay, not a triangle. Why? Because it wouldn't connect, okay? Those 3 sides would not connect to make a triangle, okay? So don't name it and be like, oh, I think it's obtuse or cute or it's right. No, it's not. The 2 short sides are way too short. They're like dinosaur hands. They're too little. Okay, so let's try this one. Is 3.8 plus 4.1, is that at least 5.2? And the answer is yes. Okay, so it is a triangle. And then we can do 3.8 squared plus 4.1 squared. I think on your homework, they don't always put the big number on the right. So just, don't fall in that for that trick. People are being sassy. So then if you do this, you get 31.25 and you get 27.04. And this is bigger, so it's greater than. So that would be acute. All right. Well, that is the end of the notes for today. We just talked about, hey, if you have a right triangle, the Pythagorean theorem will work. If the right triangle works, you have a right triangle. I mean, if the Pythagorean theorem works, then you have a right triangle. And then also, what if it's less than? That would be a obtuse. And if it's greater than the longest side squared, then you're going to have acute. And then remember to check to see, is it actually a triangle? Okay, before you do that, we'll check. All right. Well, thank you so much. I hope you have a fantastic day.